Okay, we're going to continue with our lesson on inverses, and now we finally get to the heart of the lesson, which is to use something called the inverse matrix method for solving a system. And this relates to the problem we just did where we solved for an unknown matrix. Well, it's kind of like that. So let's say we have this system of two equations with two unknowns. The first thing we want to do for the inverse matrix method is write our equations in matrix form. So we put the coefficients, -2, 3, 5, and 1, into the first matrix, which we call matrix A. Then we have our variable matrix, x, y, and then the constants, -11 and 19, go into the matrix on the other side, and we call that matrix B. So your equations have to be in standard form to do this. Now that you have matrix form, and by the way, if you want to be convinced that matrix form is the same as the equations, just multiply these two matrices together. -2 times x plus 3 times y equals -11. That's the first equation. 5 times x plus 1 times y equals 19. That's the second equation. Okay, so now once we have this written in matrix form, the next step is to find the inverse of matrix A. So A inverse in this case would be, let's see, what's the determinant of A? We have -2 minus 15. So we have -17. So A inverse would be 1 over -17 times, now we're going to switch the numbers on the main diagonal, and we're going to take the opposites of the other two numbers. And for the moment, I'm just going to leave it like that. I'm not going to multiply the -1/17 through because I think it's just going to make things harder on us later if we do. So let's leave it on the outside. The next step is to left multiply each side of the equation by the inverse. So remember we did that in the last problem too. So if I multiply by A inverse over here on the left of the left, and I multiply by A inverse over here on the left of the right, what am I going to get from the product of A inverse times A? I'm just going to get the identity. So that's going to leave the variables x, y by themselves. So really it boils down to this. If you want to know what x and y are, you're going to multiply A inverse times B. That's really all it boils down to. So A inverse times B is -1/17 times the matrix 1, -3, -5, -2, that's A inverse, times B, -11, 19. So let's go ahead and do that. Now I'm going to leave the -1/17 for now. Okay, first row, down the column, we get -11 plus -57 is -68. And then second row, down the column, we get 55 minus 38, and that is 17, I believe. Now let's multiply the -1/17 through, and we have 4, -1. And those are the values of x and y. Now let's go back and check in our original equations. X is 4, y is -1. I'm going to do my check right over here. -2 times 4 plus 3 times -1 is -11. 5 times 4 plus 1 times -1 is 19. Okay. Now, I'm not saying that this method for solving a 2x2 system is the best or the easiest or the fastest or anything. It's another way. Remember, when we learn about matrices, we learn methods, and we keep it simple for ourselves with 2x2s and 3x3s, but these methods could work for 4x4s and 10x10s and 20x20s and systems that you would not want to do in any other method. And finally, I'm just going to write the answer as an ordered pair like we would with the other methods. Okay, so we can do this by hand, as you just saw. We can also do it with our calculators. So let's do this problem again, this time using the calculator. So the first step is the same first step. Convert the system into matrix form. Then in your calculator, you're going to type in matrix A, and you're going to type in matrix B. So let's go ahead and do that. Remember, go into the matrix menu, and then go over to Edit, select A, make it a 2 by 2 if it's not already, and then type in your numbers. Then you can go back to the home screen, back into the matrix menu, go over to Edit, go down to B, press Enter. This needs to be a 2 by 1, so change those dimensions if you need to, and type in your numbers, -11, 19. Back to the home screen. Okay, now let's see what's next in our steps. Got ahead of myself there. Let's see what step 3 is. On the home screen, compute A inverse B. Okay, remember how to get to the matrix menu, we've been using this button that says x to the -1. That is our inverse button. It's been right there all along. Who knew? So, second, into the matrix menu, select matrix A. Then you press that x to the -1 button. That's your inverse. And then into the matrix menu, select matrix B. And what do we think the answer is going to be? Do you remember from when we did it just a minute ago? Same problem? 4, -1. Just like that. Okay. So here's a practice problem. I would suggest you do it. I'm not going to step through all the steps because the videos are getting long, but I'll just pause, write all the steps, and resume, and you can do the same. So the first step was to write the matrix form, and I labeled the matrices A and B. Then I found the inverse matrix, and the next step is going to be to multiply A inverse times B. Okay, so I wrote those in there. Here's A inverse, here's B. I multiplied the matrices and left the 1/3 on the outside, and then multiplied through by the 1/3. So our ordered pair is -3, 0. Okay, so then you want to go through and try that on your calculator again. Type in matrix A, type in matrix B, and have your calculator compute A inverse B. So, how about for a 3 by 3 system? Well, there is a way to do this by hand and to find an inverse by hand, but we're actually not going to go into detail on that, so I'm not going to expect you to find a 3 by 3 inverse by hand, but your calculator can do it. Let's take a look. Suppose I go into the matrix menu, and I just go over to Edit. Maybe I'm going to edit matrix C. Matrix C I already have set up as a 3 by 3, so I don't even need to edit actually. Let me just go in and choose matrix C, and then select inverse, and see inverse. It calculated the inverse matrix for me. However, I don't like having all those decimals, so I'm going to press Math, and then change to fraction, enter, and there's the inverse. So it has the constant from the outside multiplied through everything. You could factor it out if you preferred. Okay, but let's go ahead and solve the system using the calculator. What we're going to do is write the system in its matrix form. So we have 4, -1, -1, 6, 0. Notice in this equation there's no y term, so we use a 0 there. -1, and then -1, 4, 5. That's A. And then we have x, y, and z in our variable matrix. And then on the other side, we have -20, -27, and 23. And that's B. So to find x, y, and z, we're going to multiply A inverse times B. So all you would do on your paper is you would write this out. You would write out the system in its matrix form. You would write out that what you're going to do is A inverse B, but then you're going to let your calculator do it. and you're going to write down what the answer is. So give it a try, put it in your calculator, see what you get, maybe pause here, and then I'll see what I get as well. Okay, so if I look in my matrix menu, I actually put the 3 by 3 matrix as C. So I'm going to choose C inverse times, and then back into my matrix menu, the 3 by 1 was B. So C inverse times B, -4, 1, 3. That's the solution of that system. Okay, so let's draw some conclusions from this unit. We have learned a lot of ways to solve systems of equations. That has been the primary goal. The ways we've learned to solve 2 by 2 systems are graphing, substitution, elimination, Kramer's rule, and the inverse matrix method. The ways we have learned to solve 3 by 3 systems are elimination. Substitution is a method as well, but we didn't cover it. Kramer's rule, and we know how to do it by hand. And the inverse matrix method, and we know how to do that by calculator. We did not learn how to do it by hand. Okay, here is your lesson, or excuse me, your assignment. We had a long lesson. And make sure when you use the inverse matrix method that you can do it by hand for the 2 by 2s and by calculator for the 2 by 2s and the 3 by 3s. Thank you, everyone. You are awesome.